Good morning, students. In today's class, we will do chapter 10, Gravitation. In some section it is completed, but in some section it is not. So we will start with starting of the chapter, Gravitation. What is gravitation? Gravitation is a phenomenon in which two massive bodies attract each other. ग्रेविटेशन एक फिनोमिना का नाम है जिसमें कोई भी दो बॉडीज जिनके पास मास होता है वो एक दूसरे को अट्रैक्ट करती है. सो हाउ वी कैन डिफाइन ग्रेविटेशन? द फिनोमिनन in which two massive bodies attract each other. Massive body means ऐसी बॉडी जिसका मास होता है और ये दो बॉडीज हमेशा आपस में एक दूसरे को अट्रैक्ट करती हैं. दैट इज ग्रेविटेशन. देयर एग्जिस्ट एन अट्रैक्टिव फोर्स बिटवीन टू बॉडीज ऑफ डिफरेंट मासेस. That is known as gravitation. How we can measure this gravitation or how we can prove that there exists an attractive force? For that, Newton suggests a law named as Newton's law of gravitation. And according to this law, Newton's tell a relation, mathematical relation to calculate the gravitational force between two bodies. Newton said there exists an attractive force between two bodies of masses m1 and m2 separated by a distance r, and the two bodies always attract each other by a force. This force depends directly upon the product of their masses and inversely proportional to the square of distance between them. Here m1 is the mass of first body, m2 is the mass of second body, r is the separation between these two bodies. This separation is from center of first body to center of second body. When we combine these two equations, we will get a relation that F depends upon three factors, that is m1, m2 and r square. This sign is known as proportionality sign, and when we remove this sign, we will use a constant, that is capital G here, capital G m1 m2 by r square. This G is proportionality constant here. Proportionality constant means proportional sign only tells that the value of force depends upon these three factors. If we change any one of these three, the force will change, but it doesn't tell about the amount, by how much amount this change. That means, for example, if I am saying if I increase the mass of first body, force will increase, but by how much factor it is not given. For the equality sign, we will replace the proportionality by a constant. This constant is capital G here, and it has a specified name. This G is known as universal gravitational constant, and its value is fixed. Its symbol is also fixed and its unit is also fixed. That's why we name it as universal gravitational constant. And this relation is mathematical formulation of Newton's law of gravitation. By using this formula, we can calculate the gravitational force between two massive bodies separated by a distance r. This Newton's law of gravitation is also known as universal law. What do you mean by universal law here? Universal law means a law which is applicable to every body present in the universe. Same case happens here. This expression is valid for the every two bodies present in the universe. Either the bodies are very much smaller particles like electron, proton and neutrons, or the bodies are bigger one like moon, earth, sun, star. Every body which have mass separated by a finite distance, they must exert a gravitational force on another body. That's why it is named as universal law. If the question is asked why Newton's law is also named as universal law, we can simply give the answer that this law is applicable to every two bodies present in the universe. And as this law is known as universal law, this constant is also named as universal gravitational constant. Why universal word is used for capital G? Because the value of capital G, that is 6.67 into 10 raised to the power minus 11, it is same at every place in the universe. Either you will measure this value of G at a mountain, at a sea level, under the sea or in the space. At every point in the universe, the value of this gravitational constant comes out to be 6.67 into 10 raised to the power minus 11. That's why it is named as universal gravitational constant. Its symbol is capital G. You can't change the symbol. Its value is 6.67 into 10 raised to the power minus 11 and its unit is Newton meter square per kg square. How we derive this unit, that this gravitational constant has unit this? We can simply prove that by using this first equation. Here first equation is F is equals to G m1 m2 by r square. We know that the SI unit for force is Newton. We can write it by capital N. For G we have to calculate the unit. Masses are measured in terms of kilogram. So for first mass the unit is kg. For the second mass also the unit is kg. And distance is measured in terms of meter. So we will arrive at the unit that Newton meter square. We multiply meter square on this side and divide by the kg square. So it is the unit for gravitational constant. This gravitational constant have a fixed value and a fixed unit also. This is all about Newton's law of gravitation. In the next video, we will discuss about the nature of Newton's law of gravitation.